Hey guys, a very good day to you all. And now in this video, we will be understanding what is Pauli's exclusion principle. So guys, before starting with this video, you must know what is Aufbau principle, which helps us to write the electronic configuration of an element. And don't worry guys, if you don't know what is Aufbau principle, you can find the link in the description box, or you can simply click on this I button over here. I have already made a video on that. Okay, now let's get back to our main topic. So to understand Pauli's exclusion principle, first you must know certain basics. Okay, so let's understand certain basics first. There are four types of quantum numbers. Am I right? The first one is the principal quantum number. And what is the use of this principal quantum number, which is represented by n? This value of n tells us the energy level inside which our electron is present. The second one is the azimuthal quantum number, which is represented by L. So the value of L tells us the subshell inside which our electron is present. The third one is the magnetic quantum number, which is represented by M, and this M tells us the orbital inside the subshell in which our electron is present. And the fourth one is nothing but the spin quantum number, which is simply represented by S. So if your electron is moving in a clockwise direction, we take the value of S as positive half, and if your electron is moving in the anti-clockwise direction, we take the value of S as minus half. Now guys, listen carefully what I am saying. See, I have made a video on this quantum numbers and shapes of orbital. A combined video is made. And guys, trust me guys, if you watch that video, I have explained many concepts inside that one video, and that video will surely help you all to solve minimum 3 questions in your JEE Main examination, and 3 questions is equal to 12 marks. So if you are just getting 12 marks by watching one video, then guys, I think that you must surely watch that video. I will give the link of that quantum numbers video in the description box below, or you can again simply click over here, you can find that video. And that in that video I've really explained many concepts in a simplified way, where you can get lots of knowledge. Okay, so now this was first basics that we must know. The second thing that we must know is that for the value of L, which subshell is corresponding, which means that suppose if the value of L, and what is L? Azimuthal quantum number. So suppose if the value of L is 0, so the value of L is equals to 0 corresponds to S subshell. Okay, and if the value of L is 1, so the value of L is equals to 1 corresponds to P subshell. And if the value of L is equals to 2, this corresponds to the D subshell, and if the value of L is equals to 3, the value of L is equals to 3 corresponds to F subshell. So guys, quickly memorize this, because this is going to help us to understand the Pauli's exclusion principle. And guys, I have explained this everything in that particular video also of quantum numbers, so you better watch that video because it is surely helpful for you all. Okay, now moving ahead to the main principle, that is the Pauli's exclusion principle. Now what does this Pauli's exclusion principle tells us? It tells that two electrons in an atom cannot have the same set of all four quantum numbers. Now what is the meaning of this? We will understand it with the help of an example over here. Let's consider the example of a helium. And as we all know, inside a helium atom, there are two electrons. Am I right? So the first electron is going to have four quantum numbers, and the second electron is going to have four quantum numbers. As we all know that if you want to represent an electron, we have to write its four quantum numbers. Okay. So first electron is going to have its four quantum numbers, and the second electron is going to have its four quantum numbers. Now what Pauli told us was that the four quantum numbers of the first electron and the four quantum numbers of the second electron will not be same, which means that he said that there can be three quantum numbers same. That is, three quantum numbers of first electron can be equals to the three quantum numbers of second electron. But all the four quantum numbers can never be same. I am repeating myself again. Pauli said that all the four quantum numbers of first electron will never be equals to all the four quantum numbers of the second electron. There will be at least one quantum number which differs first electron and second electron. So between these four and these four, there will be at least one different quantum number. Now let's understand this in a bit precise manner with the help of accurate values of N, L, M, S. Okay, so now let us consider the electronic configuration of helium. So as we all know that the electronic configuration of helium is 1s square. Now what does this 1s square means? See, 1s2, okay, 1s raised to 2, which means that both the electrons of an helium are inside the 1s subshell. Okay, so both the electrons of an helium are inside the 1s subshell. Now this one, in this 1s, this one is nothing but the energy level. And who tells us the energy level? The principal quantum number tells us the energy level. Okay, so now let us understand it. For the first electron, okay, as we all know that inside 1s there are two electrons. So for the first electron, of course n is going to be equals to 1 because it is present in a 1s subshell, and inside 1s this 1 is nothing but the principal quantum number which tells us the energy level. So of course n is going to be equals to 1. Okay, the next one is L is equals to 0. Now why is the value of L is equals to 0? Because if you remember earlier I told you all to memorize one table. So for L is equals to 0 corresponds to the S subshell. So am I right? So since the one electron, that is the first electron, is present in the 1s subshell, therefore S is nothing but L is equals to 0. So azimuthal quantum number is going to be 0 and the principal quantum number is going to be equals to 1. The next one is value of M, that is nothing but a magnetic quantum number. So if you want to find out the value of M, what is the formula for finding value of M? It is nothing but minus L to plus N. That is nothing but minus 0 to plus 0. So minus 0 to plus 0 is nothing but equals to 0 only. Okay, so you have got the value of N as 1, L as 0 and M as 0. Now the remaining one is the S. So let's consider that our first electron is revolving in a clockwise direction. So we take S is equals to half. So now when we write all the four quantum numbers inside a set, so we are representing it in a set. So what we get? 1, 0, 0 and half. Okay, so now let us understand for the second electron. Inside this 1s there are two electrons of helium. Am I right? Inside the 1s subshell there are two electrons of helium. So for the second electron, obviously the energy is again going to be equals to 1 because it is present in 1s and 1 represent the energy level, which is nothing but N. So value of N is going to be equals to 1. And here the value of L is equals to 0. Again it is equals to 0 because it is in a S subshell. As we have already seen that both the electrons are present in a 1s subshell. So the value of N and L for both of them is also going to be same. That is N is equals to 1 and L is equal to 0. Similarly, the value of M completely depends on L. So value of M is going to range from minus 0 to plus 0, and minus 0 to plus 0 is nothing but simply 0. And as we know that the first electron is revolving in a clockwise direction, therefore we have taken plus half, and it is obvious that the second electron is going to revolve in an anti-clockwise direction because inside any orbital, okay, inside any orbital both the electrons revolve in opposite direction. Suppose one electron is revolving in a clockwise direction, so it is obvious that the second electron is going to revolve in an anti-clockwise direction. Therefore we take s is equals to minus half. Now when we write all these four quantum numbers inside a set, we get something like this: 1 0 0 and minus half. So for the first electron, these are the four quantum numbers, and for the second electron, these are the next four quantum numbers. Now when you compare the set of first quantum numbers and the set of second quantum numbers, you notice that the first three quantum numbers are same, but the fourth one is different. So this is what Pauli told us, that there can be a maximum three quantum numbers equals, but the fourth one should always be different, which means that you in a set, when you compare the quantum number set of two different electrons, all the four quantum numbers can never be same. Okay, now let us understand with a help of another example which will help you to understand this in a much more better manner if you have not understood up till now. Okay, so now let us take the example of an lithium. So as we all know that inside a lithium there are three electrons. Okay, so inside a lithium there are three electrons. So obviously the electronic configuration of lithium is nothing but equals to 1s square and 2s1. Okay, so now inside there are three electrons. So can I say that inside 1s there are two electrons and inside 2s there is one electron? Okay, so now I will first consider the first electron which is present in 1s. Okay, so for first electron, n is equals to 1. Why n is equals to 1? Because the first electron is present in 1s, and inside 1s this 1 is nothing but the value of n. So n is going to be equals to 1, and L is equals to 0. Now why L is equals to 0? Because the first electron is present in 1s, and as we all know, for L is equals to 0 corresponds to the s subshell. So s subshell will always have a value L is equals to 0. Now since L is equals to 0, M is obviously going to equals to 0. And let us consider that the first electron in the 1s is revolving in a clockwise direction. Therefore we take s as half, that is positive half. Now let us consider the second electron. Okay, see now first I forgot to jot them together. So we have written them inside a set, that is 1 0 and positive half. So now let us consider the second electron. So for the second electron is also in the 1s subshell. Am I right? So for the second electron, the value of n is going to be equals to 1. Why? Because it is present inside a 1s subshell, and 1s, in this 1s, this 1 is nothing but the value of n. So obviously n is equals to 1. Now similarly, if n is equals to 1, now why L is equal to 0? Because it is present in a 1s, and s is the value of s in terms of L is nothing but 0. So when you get an s subshell, obviously your value of L is nothing but equals to 0. And since the value of L is equal 0, therefore the value of M, which is nothing but your magnetic quantum number, also becomes 0. And since the first electron in 1s is revolving in a clockwise direction, therefore the second electron is going to revolve in an anti-clockwise direction. Now when you consider the third electron which is present in the 2s subshell, so the third electron which is present in the 2s subshell. So for the third electron, n is equals to 2. Now why here n is equals to 2? Because it is present in a 2s, and in this 2s, this 2 represents the energy level, which is nothing but n is equals to 2. So n is equals to 2. And why L is equal to 0? Because it is present in a 2s subshell, and this s has value L is equals to 0. So the azimuthal quantum number value of s is nothing but L is equal to 0. And since L is equal to 0, here obviously your M is also going to be equal to 0. And let us consider that since there is only one electron, we consider that it is revolving in a clockwise direction. Okay, so now if you again see over here, all the four quantum number values of the first electron, second electron and third electron are different. So when you compare the quantum number values for the first electron and second electron, here the first three values are same, but the fourth one is different. Okay, now similarly if you compare the quantum number values for the second electron and third electron, the two values are same, but the next two values are different. So in, if you take any of the atom, let's take any of the carbon, nitrogen, oxygen, any of the atom you consider, it is going to have four different set of quantum numbers. So can I say that inside an atom, all the electrons are going to have different set of quantum numbers? So this was what told to us by Pauli. So guys, if you have liked this video, then do check out my channel where I have uploaded chemistry and physics videos, and don't forget to subscribe to the channel. And guys, thank you for watching this video.